Okay, today I want to talk to you about a problem that I see from time to time with some of our clients. They say that there are leaking registers, meaning there is a water formation on the registers and creates a dripping problem. Sometimes it can be very annoying, sometimes it's a small issue, sometimes it can be a big issue. So today I will talk to you about three different things or reasons for which this can happen. If you think this is something useful and you are learning from this channel, please don't forget to give us a like and to subscribe. It helps a lot. So the first reason why a leaking register may be a problem for you is because there is poor insulation. When I'm talking about poor insulation, is the insulation on the ducts uh, on top of the on top of the ceiling. So let's say if your house, I'm gonna draw something like this. If this is your house, and you have the AC machine, let's say, yeah, right here, and then there is a duct coming from the AC through the ceiling, and then going into different registers. The problem sometimes is that this duct right here is not very well insulated. Now, imagine how much condensation you're gonna have here inside the ceiling, and the effect of a very hot temperature compared to the one inside the duct, which is pretty cold because it's coming from the machine. This will create the same effect as if you take a can of Coca-Cola and you put it outside the fridge. A few minutes later, you will see there is water around the can of Coke. Why? Because it's so hot compared to the temperature inside the can that all the humidity outside the soda can will convert into water. So that's the thing that happens when you have poor insulation. The insulation around the duct is so small that the water formation around the duct will end up going through the registers. Another problem that sometimes can happen, and let me erase this for a moment, is when you have a no the right returns. So now we're gonna draw the same house but in a plan view. Let's say that your house is like this, something very small, something typical. And let's say that you have the AC machine right here, and then you have, I don't know, this is a door to the outside, and you have another door here leading into this room, and that's it. So this is a bedroom, and this is the living room, whatever. Then you have ducts coming from here into here, and there is a register here supplying the living room, and there is another register here supplying the bedroom. If you don't have enough air coming back into the AC unit, meaning there is no return, and there should be one return from the bedroom into the living room. Let's say it could be a wall transfer grill where the air goes like this and like this, because at the end it needs to go back to the machine. I see some houses, some apartments where they do the installation of the AC. They have what seems to be good supplies, but guess what? There is no return. So what happens is that all the air that goes through this duct into the bedroom, the majority of it tends to stay inside the bedroom. So there is no air or a good circulation of the air coming back. When you don't have circulation coming back, obviously the machine will have to grab the air from somewhere else. It will probably be through the windows in the area of the living room. It can be from any other place. It could be a hotter air. That hotter air will go through the ducts again, and you are gonna continue with the same issue of having condensation. You have hot air coming through a machine that is not prepared for what we call fresh air. So the right air is not recirculating inside the apartment or inside the house. So remember to have always enough supplies and returns that will allow the air to come back into the machine. Now, third problem that happens a lot is when, I'm going to erase this again, is when you have a unit that is too big. So let's say, for the sake of this exercise, that this is a house of I don't know, let's say it's a house that only needs 3 tons, but you said, you know what, I'm gonna put 5 tons. Why? Because you may say, oh, 5 tons is better than 3, it's a bigger unit, and I'm gonna cool my house faster. Well, cooling the house faster is a problem, because if the optimal tonnage is 3 tons, the unit may be running for about, I don't know, let's say 15 to 20 minutes. Now, when you have a unit of 5 tons, the unit may be running, I'm just coming up with number, but let me reduce this number in minutes. These are minutes. But when you have 5 tons, the unit will only run maybe 5 minutes. In 5 minutes will be enough to cool down the house. The problem is that when the air, let's say here again that I have the AC machine in this corner, when the air is not circulating for a long time into the AC machine, it's not able to capture all the moisture that is in the air. So all the humidity that is in the air cannot go back into the air handle. And remember that all air handles, they have, what do they have? They also have what is called a condensation line. So that condensation line that is taking the water from the inside the house and dripping it outside, and that's the right way to do it. That water that goes through here, through the condensation line, is nothing else or nothing more than the water that is being able to capture inside the house. Why? Because it's running for that specific time. I was saying about maybe a rule of thumb could be 15-20 minutes. If you reduce the amount of time that the air is going to recirculate inside the house, the problem is that you are not letting the unit to have enough time to recirculate the air, to grab all the moisture, and to take it to the outside. So 5 tons is not better than 3 if 3 is what you need. So I hope this video has been helpful. Actually, I'm sorry, I was doing the video a little bit too fast, that I didn't put here number 2. I was saying no returns. And as number 3, too big of a unit. If you find this video useful, please remember to give us a like and subscribe to our channel. Thank you.